Welcome, guys. Yeah, so let's solve this stone game. Yeah, so this question is somehow like a joke. Yeah, so but it's interesting. Yeah, so Alice and Bob play again with piles of stones. There are even numbers and also positive, and each pile is positive. Okay, and the objective again is to end is the most of stones. So yeah, so and the rule is that so Alice can take the beginning or end. So Alice take first one. And Bob turn to Bob, and Bob take one, and Alice take one until no piles left. And so return true if Alice win, again return false if Bob wins. Okay. So this one is true. It says that Alice start first, and then so Alice can take 5 plus 4, which is 9. Okay, and then in this one, Alice can take 7 plus 3. Okay, so still greater. And then return true. Okay, so the answer is true. So answer is Alice always wins. So let's give the proof. Okay, so somehow this is why this looks like a joke. Okay, so suppose you have only 2 numbers, right? A1, A2, which Alice always win, right? Alice return true because Alice can take whatever, right? And if there are 4 of them, okay, so now it's interesting, right? So you'll see that you can draw this as red, and this as blue, and red. So obviously that if A1 larger than A3, greater than A2, larger than A4, suppose this is the case, then if I were Alice, I can first take A1, right? Then Bob can only take A2 or A4. Then I take A3, right? So however, if A1 plus A3 greater than A2 plus A4, then Alice can choose to take this red one. If it's reversed such that A1 plus A3 is less than A2 plus A4, then Alice can take the A4, and the Bob must take A1 or A3, and Alice can take A2, right? So by induction, so for this problem that we know that if there are 4 piles, then Alice always wins. Okay, so return true. Okay, so the answer is actually return true. Okay, so now let's go to the why all the even numbers should all be true. Okay, so the reason is simple, right? Suppose you have A1, A2, A3, A4. Let's say up to AN minus 1, AN, A2N minus 1. Okay, and then my conjecture, and I use mathematical induction. So I believe, so I assume that, so my assumption is that for any 2N minus 2 piles, and Alice starts, then Alice always wins. So this is my assumption. Alice always wins. Always win. Okay, and we need to prove that if there are 2N stones, then Alice always wins. Right. So intuitively, Alice can take all the odd term, right? And Bob can take all the even term. So if all the odd are greater than all the even, then Alice can take even. If all the even are greater than all the odd, then Alice can take odd, right? So yeah, so intuitively this is true, right? But let's try to write it down rigorously. Okay, so let's right, so let's suppose that A1 plus A3 plus A5 up to A2N minus 1 greater than A2 plus A4 plus the A2N, right? Then Alice can take what? Let's say Alice can take A1, right? Then the Bob can only take A2 up to A2N, right? So and then Alice can always take A3, right? So which give you a proof, right? So conversely, if all the even larger than all the odd, then you can also do this. So Alice can also do this. Okay, so this is why in this case Alice always wins. So the answer is true. Okay, that's it.